Welcome to the pre-stream, future listeners. We'll get started in a couple of minutes as people filter in and get everything prepped to go. Until then, here's me just kind of sitting here not doing anything, just waiting for people to come in. Probably should have some elevator music or something. That way it can be a little bit more, entertaining while I'm standing here. By the way, if you are watching this after the fact and you're seeing this opening, scrub ahead about a minute or two, and that's where you'll get to actual content. Now, if you're here watching this live, we do have plenty of functionality. Questions, I will be watching those as we go through. Chat, I'll be watching that sometimes. Those are the two main things that'll be in front of me. So should be able to keep track of what's going on. Welcome in. We'll get started in just about a minute or so. That way we'll give everybody a chance to get in. All right, people are starting to file in. Going to continue to wait for roughly 1 minute. That way we make sure everybody's able to get in before I kick off this presentation on developing a solution with SQL Server Machine Learning Services. Okay, let's get started talking about developing a solution with SQL Server Machine Learning Services. If you have questions, please drop them in the questions tab. I will be watching that throughout the course of the session. If you have chat comments, you're welcome to leave those as well. I may not be able to get to that quite as frequently. So let's talk about this solution. My name is Kevin Feasel. I run a predictive analytics team out of Durham, North Carolina. I'm a Microsoft Data Platform MVP, and I have a blog called Curated SQL. The idea of Curated SQL is I like to try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. So that's curatedsql.com. To give you an idea of machine learning services, let's do a brief overview of what it actually is. This was originally released in SQL Server 2016 as SQL Server R Services. In 2017, Microsoft added support for Python and renamed it to SQL Server Machine Learning Services. With 2019, Microsoft added Java support and also open sourced the extensibility framework, so we're able to potentially add other languages as well. These are the 3 key languages as of today. So what I want to do in this talk is introduce you to ML services, give you an idea of when it can work out. We'll very briefly talk about installation configuration, and I'll walk through a basic project that uses external script execution to run R code. This is an abbreviated session, so I've got about 45 minutes to do this, which means that some of the content I will elide over. We'll be sure to give you the links to where you can grab additional resources at the end for the demos that I'm not able to get to today. That said, here is my agenda. First up, let's talk about how this thing works. Essentially, there is a SQL Server Launchpad process. The idea is SQL Server, the executable on the far left-hand side, is your database engine. Now, when you want to run R code, it doesn't run inside the database engine. Instead, it calls out to a separate process, this Launchpad, that then will launch R terminal. R terminal is where the actual R code will run. Any data will get passed over to it. Code will run in R. Data can come back from it using the BXL server process. So this is a brief idea of how this all works. It's all internal to one machine, but it's not within the SQL Server process. The plus side to that is that if R crashes for some reason, it will not take down your SQL Server. For Python, it works almost exactly the same way. It's just Python instead of RTerm. Now, SQL Server also has some built-in native C++ implementations of specific algorithms. What this allows you to do is get extremely fast predictions, extremely fast scoring for this relatively limited set of algorithms. It is limited. I have used it a few times. When I can use it, I love native scoring. But given its limitations, it's kind of tough. So ML Services essentially brings code to the data. That way you don't have to take your data out of the database, send it off to a different server, and have that server process it. Instead, we have all of our data living on our SQL Server, and we're kind of just doing an inter-process transfer of data. So no network hits as a result. We can also use Resource Governor to limit the risk of a failure based off of, say, a query that's chewing up all your resources. I have an entire talk on the administrative side of machine learning services at this link right here. And what I'll do is I will copy the link and paste it into chat just in case you're interested. There you go. So, okay, what works well with ML services? There are a few key scenarios. If your data is in SQL Server today, machine learning services is more likely to work for you. Ideally, you'll have batch processing instead of one-by-one individual records, because there is a startup time for machine learning services. In my experience, that startup time ranges from about 2 to 5 seconds. It sometimes is lower, but usually it'll be about 2 to 5 seconds. If you can use native scoring, that really pushes in favor of machine learning services. One scenario that we learned about in practice was that the interaction between R and .NET code is not great. There is a package for R.NET, but it's not a good one. I mean, no disrespect to the people who've developed it, who've worked on it. It's just it's a complicated scenario, and I don't like the way that it's been implemented. Meanwhile, SQL Server Machine Learning Services gives you a way that I can call my R code from .NET through SQL Server. On the downside, if you need single hit near real-time predictions and you cannot use native scoring, this is a terrible solution for you. That 2 to 5 second startup time will kill you. We had a scenario where we needed roughly 100 millisecond response time max. And with that 2 to 5 second startup, we just couldn't do it. If we batched together 5,000 items, yeah, that's okay. We can deal with that. But we weren't batching them together. We were trying to do one single operation at a time. If none of your data lives in SQL Server, it doesn't really make sense to bring it over to SQL Server. And also, ML services can be CPU intensive. When you think about it, we have Python and R running on the same machine. If you're, say, trying to build a neural network and you don't have GPUs, that's going to burn a lot of CPU power. So please do keep that in mind. Also, Azure SQL Edge. This is recently gone into GA. This is a version of SQL Server intended for IoT and supports ONNX, the Open Neural Network Exchange. I am quite excited about the possibilities of this because it allows you to perform native scoring on neural network models. And the neural network models could be trained in TensorFlow, in the PyTorch, Caffe, CNTK, whatever library you want. There is a way to translate that into this Open Neural Network Exchange format and use it. The on-premises SQL Server 2019 and pretty much anything except Azure SQL Edge today does not support ONNX native scoring. Only Azure SQL Edge does. So I'm hopeful that this will be brought into other SKUs of the product and that I'm able to run this on premises. Briefly, let's install SQL Server Machine Learning Services. Do it through slides because it'll be a lot faster that way. So we kick off a new installation or add features to an existing installation. There are two separate options. By the way, this is SQL Server 2019. The screens will be a little different for 2017 and 2016. For 2019, we have two options: Machine Learning Services in Database and Machine Learning Server Standalone. If you want standalone servers, in other words, I don't intend to install SQL Server on this machine, but I still want Machine Learning Services. That's what the bottom set is for. It is uncommon that you'll want the bottom set. You will almost always want the top set in Database, Machine Learning Services. And you can choose the languages. Whichever languages you choose, you are going to have to go through the agreement for them. Once you've installed everything, the command to turn everything on is execute sp-configure, external scripts enabled, and set that value to 1 or on. Once you've done that, Machine Learning Services is ready to go. So installation is really easy. We will have to restart the Launchpad service. So there's a SQL Server Launchpad service. And by the way, you may also want to restart the SQL Server Database Engine service as well. All right, we have gone through, got this thing installed. The next step is to install packages. There are about a half dozen techniques that you can use for installing packages for R or Python. I'm going to cover the three approaches that I consider to be the best. The first best solution is the sqlmlutils library. So this is a separate package for R or for Python, and I consider it the best way to install packages on SQL Server 2019. If you use Python, you can only use this on 2019. If you use R, you can use this for 2019 or SQL Server 2017. So sqlmlutils is a separate library. You can run it from RStudio or PyCharm or your relevant IDE of choice, and it'll install packages to that SQL Server. A second option is that if you have administrative access to the machine, you can SSH in or remote desktop in or whatever. You can open up the R console and run install.packages. Alternatively, you could run pip install if you run the Python console. You'll find these in your installation of SQL Server. And I've given you the default, like if you have SQL Server 2019, it'll be msql15.msqlserver. That's your instance name. R services bin. Pip will be in Python services/scripts. The third option available to you is create external library. So this is going to require rights on your SQL Server instance. You don't need administrative access to the server, and you don't need external tools. But you have to have the grant alter any external library. And if you don't have it, you'll see an error like the message I show here. This allows you to install a package from a zip file, and generally it's specifically for your user account. Okay, so when do I use which? Well, sqlmlutils, like I said, if you're using SQL Server 2019, I'd use that as the default. There are scenarios where I've seen it not work, and I actually have an issue with the sqlmlutils team about a work project that this isn't loading for. For the console, complex packages, or when sqlmlutils fails to load. So this is what I do instead when I need to deploy that other package. Create external library is, you can use that if sqlmlutils fails, or if you want to grant people limited rights to install packages in a database. Let's do a brief demo of both Python and R. So I'm going to pop over to RStudio. It is, got to find it in my list of, I've got too many things open is the problem. Life is that way, I suppose. All right, so here's what I'm going to do. I'm going to say F11, and let's pop over to RStudio this way. By the way, if you are having trouble seeing the text, if it's too small, please put that in chat, and I'll bump up the text size a bit. So this is some basic R code, and we're going to install the R ODBC extensions package. And I think I will actually bump it up just a little bit in case. R ODBC extensions is required for older versions of sqlmlutils, but that package actually has been deprecated. So if you don't have it, here is an older repo that does have the package. Then we're going to install sqlmlutils, and you can get that from Microsoft's website. I would check to see if there's a later version. I believe it is. There's a later version now. So I can run these 2 bits of code, and I've successfully loaded the package. I've already installed it beforehand. Next up, I want to create a database connection. So I'm going to connect my driver. So here's my ODBC driver. This has to be installed on the machine that you're running RStudio. So if you're running it on your laptop and you're deploying a package to a production server, this is a driver on your laptop. You're going to connect to whatever server you need to. In this case, I'm going to connect to the local host and to whatever database you'd like to. I've also given you an example of what happens if you need a SQL authenticated account. So we'll set that database connection. Then, installing a package is actually pretty easy. SQL install.packages. We send in the connection string, and I give you a list of packages I'd like installed. This can be one package. It can be multiple packages, as I show here. My scope is based on how many people I want to see this new package. There are 2 options available to us. Option number 1 is that I can install it for everybody, and that's what public means. Option number 2 is I install it just for myself, and that's the private option. So I can run SQL install packages, and it will go out to CRAN, in this case, Case University in Ohio, and Case State in Ohio, install those packages. By the way, I can rerun these packages. So I can rerun the SQL install, and what it will do is it'll say, oh, you already have things installed. I don't need to do any more work. So it is a safe, rerunnable installation. That way you could put it into a deployment script and make sure that you've got versions of packages. If you'd like to remove a package, SQL_remove.packages. You give the same list of packages. You have the same scope options. So I can have a public version of, say, XGBoost, and I can have a personal or private version of XGBoost. Maybe they're different version numbers. So I've got a slightly older version that I want the team to use, and I'm trying out our code with the new version. So I can deploy that for me personally. I can run the code, and then it won't interfere with everybody else. When it comes time to update the packages, we would say remove.package and then install. So that way, I remove the old version, I install the new version. And here I get warning messages basically saying, hey, these are already installed, and there are actually newer versions available. So to install the newer ones, I would remove and install. I can also install custom packages, which I'll get back to in a moment. So next up, go to Python. No fancy Python UI in this scenario. I'm just going to have the console. And I'll bring this over. What I'll do is import a couple of packages. Yes, I'd like to paste. Oh, so this is the wrong Python. Okay. So, you know what? Let's skip the Python one for time purposes. I've got several versions of Python on the machine. The one that I opened up is not the correct one. But to give you a rough idea of what this looks like, let's bring up the greatest development tool ever created, Notepad. Just talk through this code. sqlmlutils is a package that would be installed, and I could install it separately using pip install. From this package management scope, I'll load up the scope. I need to connect to my database. So here I would connect to sqlmlutils.connectioninfo. I would say servers, localhost, database, expense reports, just like in R. The Python executor is going to have my ability to install packages. So I have my package manager, SQL package manager, SQL Python executor. The combination of those two will let me install, for example, the Werkzeug package. In this case, there's a flag to say upgrade it if this is not the latest version. So upgrade equals true, and I'll have two scopes, public and private scope. So by default, if you are not a sysadmin, running this alone without specifying the scope will just install for your account. It will not install public. And I can install and uninstall custom packages as well. So everything works out about the same as the R version. So let's go back here. Talk about what happens. We've installed some packages. Now what do we need to do? And what we're going to do is execute a script called sp execute external script. If you've worked with dynamic SQL before, you have xp execute SQL, and we use that to run dynamic SQL. Well, there's a similar script for external scripts. Execute sp execute external script. We send in our language, which is R, Python. It can be Java. In the future, could be other languages as well. And we get the script. The script will be a string that will have the contents that will be sent out to the remote process. So in this case, I print out the text, hello world. Here's an example in Python. Notice that print is exactly the same. So pretty easy. Now, I gave you just static hard-coded strings. I can use variables. So I could say, instead of specifying a script, I can say, okay, @script equals @remote command. This will allow me to build up my script dynamically as I need it. Machine learning services will take my input data. So in this case, this is a SQL query. I'm querying some table and I'm getting data. ML Services turns this into a proper data frame. For R, it is a data frame. For Python, it is a pandas data frame. The input data one name will be the name of that data frame. We can also send in parameters or input variables. So, for example, here I've got a trained model. Now, this is an output variable. So I can get input and output both. Basically, I'm going to create a variable in R that is called trained model, and I'm expecting to fill that with my trained model, saved as a binary. And I am going to have a variable outside of the command, so that way I'll be able to access the trained model after I've run this R script. So let's go a little bit further, build out a project, do some work with machine learning services. Here's our scenario. Our organization was working, and our accountants figured out that there was some expense report fraud among several employees. So employees were allowed to send in expense reports up to $40 without a receipt, but anything above $40, we needed a receipt for it. So several employees started spending, say they would spend $10, they would report that they spent $40. Management wants to figure out how much we think employees took above and beyond the expected amounts. So the policy changed within a certain time frame, and we noticed that there were changes to the data. So let's take a look at that, try to understand the problem a little bit more. And to do that, I will pop up Azure Data Studio. So I'm using my expense reports database, and what I'm getting is expense report data. What I want is the calendar year, the number of expense reports, the total amount spent, and the mean amount spent. If I run this, I'll get back some numbers. What I'd like to do then is break this out. So we have categories of expense, which let me show you what those mean. We have inexpensive cities, moderately expensive cities, and expensive cities. And if I visualize this in Azure Data Studio, I can use Sanddance. I'm actually going to bump this back a little bit so that we can see what's on here. Let's use a scatter plot. Our x-axis will be calendar year. Our y-axis will be the mean expenditure. And we have it broken out by expense category. So what we can see, you can see the squares have moved up a bit for our inexpensive cities. And it looks like they haven't really changed for the other two. So it looks like 2017 was when this event started. It was when the switchover happened. And we can see 3 years where, by my eyeballs, that does look like it's a bit higher. So that's the basic idea of what's going on here. We have these 3 years where the expenses look like they've gotten higher for inexpensive cities and look like they've stayed the same for the other two. So what we want to do, now that we have a concept of what the problem is, let's apply machine learning techniques to the problem. We're going to use R and Python both to build models that'll help us generate those expected amounts. So to build an R project, with RStudio and R tools, we can say File, New Project, New Directory, R Package, and you'll get this screen. You can fill in your details of what the package name will look like and what it'll be a subdirectory of, et cetera, et cetera. After adding in the code, we'll go to Build, and inside the More option, there's the option to build packages. You can build a source package or a binary package. If you build a binary package, if I build it on Windows, it'll only work on SQL Server for Windows. If I build it on Linux, it'll only work for SQL Server on Linux. If I build a source package, it'll work for either edition. For Python projects, using PyCharm, you could say New Project, fill in your details, create your virtual environment, load in whatever code you need, and build out a wheel file that way. So I could say New Python package, I can fill in whatever I need to do. If I come over to my R code, we're going to focus in this demo on the R side as opposed to the Python side. But at this point, the semantics are pretty similar. It's basically use the language, use this third-party tooling that you know, build out the appropriate package, whether that be an R package or a Python wheel file. And here's what we've got. I have some code here that is in a project for R. I've got a train models and a generate predictions. Train models basically has a few functions. One of them is train model. This is our main function that we're going to call. It takes in an input data set and a model type. Model type will be a string. It's going to be linear or XGBoost. And if it's neither of them, we throw an error and we say, hey, I can't handle this other type of model. If it's a linear model, we call this function. If it's XGBoost, we call the other one. For a linear model, we're going to run the ML Services RxLinMod. What we're predicting is that the year and the expense category will help us predict the amount for an invoice or an expense report. For XGBoost, we're going to load the XGBoost and data table packages. So I've already installed those on this machine. I'll set the label to the amount. I want to predict how much money we spend. And my input data will be a matrix of expense years and expense category IDs. And then I build out essentially decision trees that have run through a lot of possible scenarios and modifications of the data. So we get hopefully the best decision tree possible. That's very high level layman's term of what XGBoost is doing. When I'm ready for this package, I can come over, like I said, to the Build tab, go to More, and I can build either a source package or a binary package. If I want to run this on Linux and Windows, I will build a source package. Doing that kicks off DevTools build. There are some prep steps that are necessary, and I have instructions on how to do that, but basically we won't go over that right now because of time. So we're building a package. Similarly, we could do this in Python as well. We've got Python code that can be used to, say, build up a PyCharm project and deploy a wheel file. Let's now look at the SQL Server side of things. So with sqlmlutils, we can deploy this custom code pretty easily and start using it. What I'm going to do is start showing you the database infrastructure that I need to set up first. So I have a model table. This model table is where I'm going to store my models. You may be a little concerned that, hey, why are we storing models in the database? Like, I wouldn't store images in the database. That doesn't seem like a good idea. So the reason that I want to store models in the database is really twofold. One is to allow me to do native scoring, and two is because I need to get the model somehow. And I could store the model on disk if my account has the rights to pull stuff back from disk. Pulling things from disk in SQL Server is not an easy exercise. I'd have to use some sort of like XP command shell or a CLR operation, or maybe even having to run machine learning services and load it from disk. Security by default on SQL servers with machine learning services does not allow you to access disk directly outside of a temporary folder that is created for your session when you run machine learning services. So this is as of 2019, by the way. What that means is, again, reading from disk is actually harder than it would first appear. We would have to grant the rights explicitly to the account, and then in our SP execute external script, we'd pull up that data. We'd pull that data off of disk. It's a lot easier just to put it into a table. These models also tend to be fairly small. You can build very large neural network models. I mean, 50, 100 megabyte models. You could build gigabyte models if you have enough data. But the types of models that we're going to be storing today are measured in bytes or maybe single-digit kilobytes, so not that big. And in working this in production, A lot of models will also compress really well, so I can use gzip compression and save even more space. So we're going to create that table, create a stored procedure, train ML model. This takes in a language model type and a trained model. And what we're going to do is build out a SQL statement. Our SQL statement basically pulls in all of the data prior to 2017-0101. There was no fraud before that point. That was before the rule change happened. If the language is R, we'll say, call train model in expense reports and send in expense data as my input, so the results of this SQL statement, and whatever my model type was. So I set that down here. For Python, I'm just going to run it straight. I'll import Feasel, I'll build a random forest regressor and train that random forest regressor. So I've got regression.fit, expense data, category and year. Expense data amount is what I want to predict. And I'm going to serialize that data using pickle. So that's the command that I'm going to execute. So that's @script. @language is the language we pass in. Input data is my SQL statement, and I'm going to call that data frame expense data. We'll output a trained model. So in both cases, we can see trained model equals, and then trained model is set. So we'll get that trained model back out. Now, I created a variable up here, trained model with no underscore. It is a var binary max output. I just did that to show you that this variable name that is referenced in the parameter does not have to be the same as the variable name that you're working with outside of the execute external script context. But in practice, I would highly recommend that this be named the same. That way it's less confusing. So, let's give this a go. And I'm going to see if I have the package installed. We're going to find out together. So first up, let me do this just for Python, random forest regression. So I can run this. I say Python random forest regression. It's going to pull the data prior to 2017, run it into Python, execute an external script that will build a random forest model, train that random forest model, and print the trained model to screen. So we can see the trained model is here. It's just a bunch of binary. So that worked. Everything's good. Here is my second procedure. I like to have an internal procedure specifically for running ML services. That way I can run this myself and test without affecting any tables. I then like to have a wrapper procedure, a parent procedure that will call the inner procedure and then take those outputs and do whatever we need to do with them. So in this case, I'm going to insert the results into the model table. Let's truncate the model, and I'm going to run each of these. If it fails, that will mean that my R package was not installed correctly, and I'll just reinstall it and run the script again. But I believe I still have it installed. So linear model, XGBoost, random forest regression. While these are going on, by the way, let me pop open a Windows Explorer, and I'm going to go to the Developing Machine Learning Services into my expense reports package because, I mentioned source and binary packages, but I didn't show you them. So this is a source package. It is tar gzipped. This is a binary package built on Windows. I can take this and I can load it using sqlmlutils directly if I'm running on Windows. But I can take this one and load it anywhere, Windows or Linux. The process to deploy that script is right down here. So SQL install.packages. In this case, I'm loading the binary version as opposed to the source version. and I would set repos equals to null. Basically, don't go out to the internet to try to find this thing. It is instead this location on my local disk, or I can do that on a network share as well. Okay, looks like we have trained some models, so I can see some results here. To generate predictions, I will similarly have R project and then my Python code. So generate predictions in R, I have a function that takes an input data set, a model type, and a model that you have already trained. We're going to load RevoScale R and determine what type of model it is so we can generate predictions off of that. We're going to deserialize the model and run predictions off of it. Same thing with XGBoost. We'll deserialize the model, we'll prep the data, we'll run our predictions. Relatively few lines of code, does a pretty good amount of work. So here's generate predictions ML. I have my SQL command, which is getting data after January 1st of 2017. That way I get the idea of what the predicted results should be and what my actual numbers are to give a feeling for how far off they are. My trained model, I'm going to pull that from the model table given specific details. And if I'm running an R model, then I'll load the expense reports R package and call generate predictions, sending in my expense data, the stuff after 2017-0101, the model that I want to run, linear or XGBoost, and the trained model that I've pulled out from the database. I'm going to pass all of those into R, let it do its work, and give me back an output data set, which will be a SQL Server result set. For Python, similarly, build the data frame of amount prediction and predict, based off of this expense category and year, what the expense should be. Then output data set will combine together my input expense data and my predictions. This will give me back a table with result sets, and I've got my inputs as well as the amount and the amount prediction. So I can run this to build the stored procedure. I can execute the procedure itself. What I'm going to do is load up all of my predictions and insert them into a predictions temp table. Then I'm going to query the results of that temp table. So I could do more stuff with this, like load it into a permanent table or make it available to an application. So let's do XGBoost first. Each one of these will take a moment, but they will return results. And what I'm looking at is, here's the amount prediction, and to get a feeling for how close the two are to each other. And to get that feeling, I'll have the mean absolute error and mean absolute percent error. So this is how far off we are. This is what percent off we are. And here we can see like 14, we're off by 14 in terms of our prediction, and 15% difference between these two. So MAE is basically the sum of the amounts predicted minus the sum of the amounts, and then you take the absolute value of that and you divide it by the number of records. So in other words, our average of the 74 expense reports for Barrett Bondin was off by $14. That's why this sums up to more than $1,000 difference. It's 14 times 74. In other words, we're off by 15%. Everybody is off by a fairly high amount. This is actually not that great of a prediction, because we know that only certain people were, in fact, committing fraud. So let me show you a different example, the Python random forest regression. This is not about Python versus R. An R random forest regression would return about the same results. Here we have, okay, we're off by 3%, 3%, 2%, 0.5%. And then you come down here and, yeah, this person is off by 39%. And by the way, this person was committing fraud. So now we have a much stronger model and we can get a better feeling for what the difference is. That the difference here is about $15 per expense report in the inexpensive cities. Interestingly, the moderately expensive cities also are showing that there was fraud. So what was happening was that in a moderately expensive city, they might spend $35 on a dinner, but report $40. So if I scroll down a bit more, I can see the other people who committed fraud. Here's one person. Here's a person who did as well. And here's another person. So I get to see those people who did. And for the people who didn't, we have kind of bouncing close to zero, where sometimes it's positive, sometimes it's negative. So that gives you an idea that our model is pretty decent. So wrapping things up, SQL Server Machine Learning Services gives you the ability to operationalize R and Python effectively. It can give you a way of building machine learning models and bringing them to production. If you would like to learn more, if you want to grab the slides, get the demos, get links to additional resources, go to csmore.info/on/ML Services Dev. If you have questions, please feel free to reach out to me. My email address and Twitter handle are on here. And if you want to learn more, maybe reach out for consulting services, I am available for that too. So with that, let me paste in the link into chat and say thank you so much. If you have questions, drop them in the questions tab, and I'll be here for a couple more minutes as we wrap everything up. So thanks, everybody. So how about C4.5 or Bayes? Yeah, there are plenty of other algorithms that would be available. Are these supported? So I'm not sure about C4.5. I'm not actually positive what that is. Bayesian techniques, yes, they would be available within R especially. Stan, the language, not directly. But if you have, say, an algorithm that you bring in that has support in R, then yes, you could certainly use it. You can use any custom Python or R code. You're going to be limited to those languages, though. So if you want to use Stan for the Bayesian work, unless you basically take that code and convert it to R, it won't quite work out. Hopefully that answered your question, Nick. Oh, I see. Okay, the C4.5 algorithm. So if there's an implementation of that in Python, which it looks like there is, so yeah, you could use the C4.5 algorithm. There is a Python implementation of that. Basically, you'd just install the package, or you'd create the functions yourself and execute them. Okay, I appreciate it, everybody. Take care now. Have a great rest of your conference.